So we pretty much finished chapter 8, except we kind of skipped a unit so we could take the test. This unit was 5.6. Ooh. Five point six, inverse relations and functions. Okay, we're gonna do a little warm up. I am thinking of a number, and you guys have to come up and tell me what number I'm thinking of. Okay, Benj, you got it? No, it is not.
Wait,
No, no.
what?
I'm not out of like 1,000, a million, a trillion. No. Wait. When I take this number, Declan, when I take this number, I multiply it by 3. I subtract 5. I'm left with 16. What was my original number? Yeah, I'm gonna write it. No. First, I multiplied by 3. Then I subtracted 5. Shh. Let everyone do it. Then I was left with get 16. What number was my original? Talk to your neighbors next to you.
Oh, 45.
What's what? What's
Well,
Ben? Oh. Can you write down what you did back? Yeah. I do want to see that because if I had to read that, I would only be like half. I know, I was scared that it was gonna like leave a mark, but it doesn't really leave any.
They have highlighters that do it too. Erasable highlighters. Okay, raise your hand when you got it. Okay. Okay. Show me with your hands. What number do you think it is? I think it's 2? 7. This is 9.
6.
This is 7. Yes. 7. 7. No. No. It should have been 7. So original was 7. So we got this. We took our original number. Let's call it x for now because we didn't know it. Multiplied it by 3. We subtracted 5. And we got our 16, right? So let's call it f of x because that was our output. Now, Declan, you said you did the reverse, right? Okay, reverse this for me. What did you do first? You took 16, right? Add 5, then what? Divided by 3. Great. We're gonna call that g of x. So we use these two different functions to get our number, which was 7, right? Okay, we're gonna do some compositions. I want you to take both of these functions and find out what these equal to when I do f of g of x and g of f of x. Do we want to do this together in groups on the boards? Or, yeah? Okay, cool. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great, we're gonna do 3 groups of 3. I'm gonna count you off. 1, 3. Declan, what number are you? 2. Lucy, you're 3. Okay. We have bullets. Oh, this is 1. 2 has moved to somewhere over there. Oh no, never mind. In the back. And 3 is on the doors. 2 is in the back.
Hey.
Yep.
Let's go. Let's
So,
go, Jade.
one.
Yeah, you ever stand up too quick and you like when I
Oh, we're solving FOG.
this week. So are we supposed to solve it? Yo, why does it feel so close? Oh, you can move it?
I mean, we help push just so it doesn't fall off the stuff. We don't want to lift it because they don't really fit in there. And then it's always weird.
Oh.
So are you gonna solve it?
Could I erase it?
Yeah.
Okay.
Guys, I'm giving us a 5-minute timer.
Yo, bro.
We're just gonna plug it in, right? As it.
Oh yeah, but oh, do you just yo?
Just solve it. You ever want me to not do it?
Wait, I don't even. We solve this one.
Yeah, really.
Okay, then it's 3, right? Yo, bro. Wait.
I mean,
Oh.
this.
Oh,
I
I
got
got
you.
you.
Doing it on the woods.
Yeah.
It's been a long time.
So x equals 0.
But hopefully I do.
Oh, like problem sit up.
Yeah.
Okay, I was trying to figure out think about which problem I should. But
Yo, bro, take it. Take it. I'm not even like, take it.
Are you fine with Pi Day on Thursday?
absolutely. This proof we can do for fun, needle one. Oh, we don't have to.
It's gonna be nice.
Or you can just.
But yeah, Jason. Yeah, so multiplying, that's dividing it, so they just cancel it out.
After so wala na to, so wala na dito.
Wait, what? What she said?
So you can just run the tree. This.
Oh, yeah. So it's x plus 5 minus 5 equals 0. That's literally what I said. So x.
Yeah, galing.
Bro. G is x plus 5 over 3. Where'd you get? Yes. Where'd you get the 3? Huh? Yo, bro, what?
Pinag-in niya lang yung
3?
yung 3x minus 5 dito sa x.
Oh, you I see. And then, you want me to solve it?
Yes.
Okay, so
I'm gonna shock that. Will you pause the video? Because I'm gonna shock it if I touch it, and I don't want it to shock it and freeze it. There's a pause button on the very top. Any 3 of you. Just every time I touch a
Right
computer.
here?
Yep.
It's okay. You know I already had to do this. It's just recall. But the next important thing is happening next. So these both equal to x, which is actually telling us that these are inverse functions of each other. This was a way to check that these are 2 inverse functions. So we're going to write that. We use composition to verify inverse functions. So to verify f of x and g of x are inverses, use composition to show that f of g of x equals x and g of f of x also equals x. It's a good way to verify that we found inverses. We're going to talk about more inverses in a second.
Is the first, does it say to verify?
Yeah, I don't know why the 0 is now missing. Yep, 2. So I want to make 2 tables for our functions. While you guys keep writing. We had x, and then we had f of x equals, Declan, what was it? F of x equals, look up above on your paper. 3x. What was the function? Yep, minus 5. What do we put in for x to get out the 16 that we needed? 7. Yep. Now, what if I said 19? If I said that this is for everybody, not just Declan. If I said I got 19 as my end number, what was my original number? 8. Yep. Now I'll make a table over here for x and g of x, which was x plus 5 over 3. What is my x value for this equation when I was trying to go backwards?
Wait, what were you asking?
What was my x value that I had to plug in here? It is 16. And then we were going to 7. Because this was the function that was getting us our original number back. This one is when we plugged in the original number. Now I plugged in 19 here. Wenzel, what would I get out?
8.
Yeah. See how these tables are just switching x and y values? So this tells us that these are actually inverse relations. So I'm going to write this down. So these are my outputs. And then our outputs become inputs of our inverse function. So when a rule undoes another rule, we call it an inverse. I'm going to switch down. Lucy, Declan, do we need a move? Are we good? Yeah? Okay. So, an inverse relation is formed when the domain and range reverse. So I was looking above, our domain is our x values, right? And y values is our what? Kian?
It's
Yep. which is also domain, or is that range? Range, yep. So if I took my two tables, I'm gonna put them in boxes. Kind of like what we did for composition functions. We had domain of f, which was 7 and 8. Then we went to our range of f, which was 16 and 19. This was our range of f. Now, the inverses, we flipped them above. So this side became the domain of g of x, and this became the range of g of x. So all you gotta do is flip the table for inverse relations. So since we flipped the tables and we looked at the compositions of these two, and they both equal to x, domain and range flip, these are inverse functions of each other. But there's a different notation we have to write for inverse functions. So the inverse functions of f of x is written as, I'm just gonna write it first. Does anyone know how we say this? Or any ideas of how we say it? A lot of people do go with that. Anyone else have any other ideas? Okay. Anyone else have any ideas? Did you all take geometry last year? Yeah? Everyone, no? Okay, it's okay if you didn't. Oh, wait, did you take it in the past? Yeah. Okay. How do you say this? Sine of x, right? If I say, if I write that, what do you call that? Think about it. Well, this is sine of x. This is sine of x. How do you say this one? Not -1. Say it again? Yes, inverse. So this is the inverse of sine. So down here, this is f inverse of x. So as written below, if we have the composition of f inverse of x, this should always equal x. Always equal x. This is a good way to check it, to see if it actually is written as x. Now, did you like the guessing and thinking of a number? Yeah. I heard one yes.
We paused it, by the way.
Did you like, what? No, this entire time?
Oh, when we were working on the board.
Oh, I unpaused it. Yes, unpaused. Do you guys like the I'm thinking of a number? Yeah. Do you want to do another one? Yeah. Yeah? Okay. Do we have any questions about what we've gone over so far? No? Okay. Okay. I'm going to scroll up. Okay. I'm going to write these down. I am thinking of a number. First step, I'm going to add 2. Then I'm going to multiply the number by 5. Oh. You didn't see that, Kian, right? Okay, perfect. No. Subtract 3. I get 37. Write me my f of x in this situation. And we're going to do an algebraic way to find g of x. I have my number. Don't know what my number is. Let's just call it x. I'm going to add 2 to it, multiply that all by 5, then I'm going to subtract 3. And my output will be 35. So in this case, it's f of x. 37, yes. Yeah. Trust what I write nowadays.
I don't know how to write that down.
So, x is our then I multiplied all of that by 5. And then I'm going to subtract 3 from whatever.
Oh, it's 8. Is it? Oh, yeah.
Okay. Oh, good. I have my x. I'm going to add 2 to it. Then whatever this is, PEMDAS, I'm going to multiply it all by 5. And then whatever that is, I'm subtracting 3. Did we all get to this point? Did anyone get my original number already? Okay. Raise your hand if you think you got the original number. Okay, we're going to sign it. Do you all know how to sign? Okay, I'm going to... Okay, ready? This is 1. No, this is 1. Palm facing you. Yes. Palm facing you. 1, 2, 3, 4, 5. Flip your palm. 6, 7, 8, 9, 10. Yep, 10. So, yeah, 6, 7. So, what was the answer to this?
How do you do 10?
That's 7. That's 6.
Yeah, how do you do
10. 20. Yes, that's my favorite number. Did we do this?
No, I took sign language in 5th grade.
You know that I know ASL.
Wait, tell me.
Yeah. Hello, my name is something. Cause you did it.
Lucy.
Ah. Lucy. Mhm.
Oh gosh, yeah.
Hi, nice to meet you.
Full sign language?
I mean, I'm intermediate proficiency.
Like you could
I
have
know
full
it's not
sign
allowed
language.
to
Yeah, I have like a micro credential in ASL from my college. Store I like to go. Yeah. Well, if you guys ever want to do brain break, we can do that, and we can learn sign. Yeah. Cool. Okay, but back to this. We should have gotten x equals 6. X equals 6. Sign language 6. 6. 6. Yep.
How high do you know how to like sign up to in numbers?
Like 100, because it's pretty easy once you get up there. But then after 100, it's just a lot of moving. Okay, if this was x equals 6, I want to get my g of x function. I want to find the inverse of that. This actually, we're going to do the algebraic way for this, okay? So flipping colors, we're going to do this algebraically. I have f of x, I'm going to change to y, okay? Y equals 5 x plus 2 minus 3. Benj, I love that you want to learn to sign, but this is very important. Okay. Now, before, remember when I say we switch our domain and range? Yep. Range is our x values. No, our domain is our x values. Our range is our y values, right? Yes. So if I switch down the table, I'm going to switch it right here too. I'm going to switch them. Just Instead of y, write x. And instead of x, write y. All you're doing is switching. So this is going here, this is going here. Switch. You're gonna see.
Whoa. Oh.
Switch.
Switch.
Switch, and then now we have to solve for y. Switch x, and so now I'm solving for y. So I gotta get y all by itself. First, I'm gonna add 3 to both sides. So I got x plus 3 equals 5y plus 2. Desi, what do I do next?
Distribute?
Do you want to distribute? You can distribute at this point. I wouldn't recommend distributing. You can also just divide both sides by 5.
Oh, yeah.
Yeah. Let's just divide both sides by y. No, y by 5.
By 5?
Yeah. X plus 3. It's a long day. What am I left with? Yell. What's left on this side?
5, no, y plus 2.
Yep, y plus 2, because these cancel out. Okay, Jade, what do I have to do next? I want y all by itself. Yep, subtract 2. So I end up with y equals x plus 3 divided by 5 minus 2.
Wait. Oh, you just read.
Yeah, I just flipped it so my y's on that side. Guess what? This is actually the inverse function of our original function. This is g of x. This is my inverse. How do I also write inverses instead of g of x? Y, just regular y? Or is there something up top? And that's y inverse of x. Do you want to check it? I think we do. Let's do composition. Let's check. Do f of inverse of x. What should we get out?
What we got in the last
What did we write in our notes above? What should they all equal?
one? X.
Yes, x. So check it. See if it's true. Okay, that was the answer to people in the video. So when I put these on Desmos and I graph them, I get these 2 lines. They don't look anything alike, right? Kieran, do they look alike? No. I can't make a table, but if I add this line, y equals x, it goes right through them. This is actually the line that they were reflected over, okay? So I took this one, let's find a point. Well, what was our number? What were we trying to find again? Oh, 37. Okay, so 37 equals Oh, this was my old equation. This was 16 and 3. Sorry, guys. Where is it? This is actually the first one. Okay, just trust me. It's 16 and 7. Right around... Oh. There. 7 and 16, right? So if this was the inverse one, then this should have been what? What point should be on this line?
16.
Yes, 16 and 7. Let's see if we can find it. Did I write it right?
The green one.
Oh, why is there a negative 2 on it? There we go. I don't know why there was a negative 2 on it. So 16 and 7. Why is it still wrong?
There is a -2 on it.
What was the inverse function?
-3 -2.
Oh, because I wrote it wrong. Isn't that hilarious? There we go. Third time's the charm.
What?
Okay, this was our original function. This is actually just problem 1. This was our inverse, right?
Oh.
I just kept writing it wrong every time. This should be 16 and 7. Boom. Right there. What line went through the middle of them? Y equals x. It's just a reflection. An inverse is just a reflection of the line y equals x. Yes, it is 16 and 7. If I go right there, this point. 16, 7. Mm-hmm. So this is the last thing we're going to put in our notes for today. The graph of the inverse of f of x is the reflection of graph f of x over the line, what was it? Can anyone remember? What did I just say a second ago? What was the most important line? Y equals this was my original. This was my inverse. Yep, reflected over y equals x. Okay. This was the end of chapter 5. You have already been tested on this. So we're not gonna test you on this like anytime soon. But inverses is still a very important topic to remember. 2 things to remember. One is that we reflect it over y equals x. That, and then how to find an inverse. Which I didn't write. Okay, this is important bit number 1. We're going to write important bit number 2. Awesome. I didn't formally write it. Back up here, we had to do 2 steps. We had to switch x and y, and then we had to solve for y. I'm going to write it down below in words for us all. So to find the inverse of a function, switch x and y, then solve for y. And I would also, remember, you can check inverses. by doing f of g of x and g of f of x. They should equal x. Moving forward, we're going to do exponentials and logs, which I know are new words for us. It's going to be a lot of new things, and we're going to go super slow with it, starting tomorrow. Logs and exponentials. No, logs, like L-O-G. Okay, don't write this, but it's L-O-G. We're probably not even going to get to logs until next week, but we're going to talk about exponentials tomorrow, which are actually inverses of each other. So we're going to see inverses come up a little bit more. So that's it.